Good afternoon, everybody. I hope you're having a wonderful day. We are going to have our last podcast of Chapter 7 and 8, and we are going to talk about molecular, complete ionic, and net ionic equations. The first part is the molecular equations that all of you have been doing a really good job on the prior homeworks. So I think this first part should be pretty simple. We are going to show the complete formulas of all reactants and products, everything that's involved in the reaction. So let's just go ahead and quickly write this. We have aqueous potassium chromate, so this is +1 minus 2. This is +2 minus 2. Yields barium, which is +2 and -2 for chromate. Potassium is +1, nitrate is -1. So if I go ahead and write this, I will have K2CrO4. It tells me that it's aqueous, plus aqueous barium nitrate. Yields, so my equal sign, barium chromate. And it tells me that it is a solid plus potassium nitrate. And that also says that it's aqueous, which we know by now that all nitrates are aqueous. I do need to balance this equation. I have 2 potassium on the left and 2 potassium on the right. So here's my molecular equation. That's what you've been doing on all of your homeworks. And so you have added these two mixtures together. We get to see a solid precipitate. We've done many labs on this already, so you should have a good picture of what you're looking at in the spot plate. Well, now we want to talk about our complete ionic equations. And so it says that some ionic compounds separate into individual ions when dissolved into water. So when you're thinking ionic, I hope you're thinking that there's an electron transfer. We have a metal to a nonmetal. We have positive to a negative. So we have all these different things in terms of looking at ionic. Now, this better represents the actual forms of the reactants and the products. So what you want to do in the ionic equations is you want to separate the aqueous substances. And what this means is what are the ions that are actually made up of for those aqueous substances. So the first thing that you had potassium chromate. Well, you can see it was K2CrO4. So that's aqueous. So I have 2 potassium ions for every 1 chromate ion. So we separate it with their charges. Barium nitrate, we had barium with its +2 charge, +2 nitrate ions. And if I take a look at my left-hand side of the equation, these are all the reactants. So you need to keep in mind that when you pick up a bottle of this right here, of potassium chromate, it is really 2 potassium ions swimming around with 1 chromate ion. Obviously, there's many of them in the bottle, but that's the ratio that you are going to have. And then I mix them together. They rearrange in this double replacement reaction, which I forgot to mention. It is double replacement. And when they rearranged, I formed this solid precipitate of barium chromate plus potassium nitrate. And so I didn't separate the barium chromate because that made a solid. But now I need to separate the potassium nitrate into its 2 ions because that is another aqueous substance. All right, so that's my complete ionic equation. I separate the aqueous substances. I keep all solids, liquids, and gases together. Now, many of you in the room like to be spectators. I do too. I like to go to choir concerts and band concerts and be a spectator, or a good hockey game or football game, basketball, whatever it is, and to be a spectator. Now, it's a lot more fun when something great is happening on the field. The spectators get excited, but they really they don't affect the outcome. And the same thing happens here in these equations. They don't affect the outcome, but they're a very important part of everything that's going on. So for our net equation, we are going to separate out the ones that really are not involved. So I'm just going to rewrite my complete ionic so that you can see it as an example and you're not writing over the one up above. On your homework, you're not going to have to rewrite this because you can just show all the steps. But I do want you to have it in your notes so you can see exactly what you were doing. So I'm just rewriting the equation up above. Okay, so the spectator ions are the ones that are in the same form on both sides of the equation. You need to remember that the yield sign is like an equal. So on the left-hand side, I have 2 potassium ions, and on the right-hand side, I have another spectator of 2 potassium ions. The same thing, I have 2 nitrate ions on the left, 2 nitrate ions on the right. So what I have left as my resulting part is only the ions that were involved in forming my precipitate. So I had aqueous chromate, I had barium ions in the aqueous form, and that is going to make my barium chromate. And that was a solid. Make sure that everything's balanced. It is. I have 1 barium, 1 chromate, 1 barium, 1 chromate. Okay, so that is molecular ionic and net ionic equations. So I'd like you to go ahead and take a look at your homework. And I believe, again, I have this misnumbered, that yours is homework number 5. And we are going to rewrite all of this. So let's take a look at the very first one. So we have aqueous barium chloride. So my molecular is going to be barium chloride. It says it's aqueous, plus potassium sulfate. Now, it doesn't tell you the right-hand side. Hopefully, you would look at the left and say, okay, I have a double replacement reaction. So that means they're all going to trade places. So the barium is going to form with the sulfate. I look on my solubility sheet and see that that is a solid. And I'm going to form potassium chloride, and that is going to be aqueous. I just said that this is a double replacement reaction, which helps me solve the equation. Okay, to balance it, it looks like I need 2 potassium, 2 chlorine. I have 2 potassium and 2 chlorine on the left-hand side. Okay, complete ionic, like I said, you're going to separate everything except for the ones that form a solid. So I have barium plus 2 chloride ions with a -1 charge. I have 2 potassium ions plus 1 sulfate ion with a -2 charge. I keep the solid together because that is not an aqueous substance, plus my 2 potassium ions plus 2 chloride ions. Now I'm going to cross out those spectator ions, the ones that are the same on both sides. So I have 2 chlorine on the left, 2 chlorine on the right, 2 potassium on the left, 2 potassium on the right. And you should see the result. Seeing things that I have left are the items that made my solid precipitate. Keep in mind you need to write all charges and all phases in my final answer because the net ionic is my final result. Okay, so that's my whole equation. There are a couple of twists on here, so you are going to need to do all 8 problems. You only have 7 more to do. And there's not a quiz on this, but there is one of these that will be on our test. All right, you guys, good luck in finishing this up and have a wonderful day, and I look forward to seeing you in class.